this is Olivia over at Prepaze, and today I will be teaching the first part in our series on scientific notation. Today I will be teaching on the unique product presented by Prepaze. So today we're learning about scientific notation, and the key to scientific notation is to make it the most convenient for us to write about really big quantities and really small quantities. We are building and combining topics that we have already learned about in this unit, including place value and exponents, and combining all of that information in order to answer these questions. So as examples today, I'm going to be answering two questions. How wide is the Milky Way galaxy presented in scientific notation? And how long is a bacterium? So according to NASA, the Milky Way galaxy is 1 quintillion kilometers long. So that is a pretty big size. And imagine you're a scientist and you're writing down your report. You do not want to write 16 zeros, not 16, 15 zeros in a row. That's a lot of zeros. So we create what we call scientific notation to help minimize the amount of writing that we have to do. So let's think about 1 quintillion for a moment. 1 quintillion is the same thing as multiplying 1 times 10 times 10 times 10 times 10, all the way we're multiplying it 17 times in order to get our value of 1 quintillion. So we can represent quintillion as a product of 1 multiplied by a series of numbers of 10 to represent all of those place value movements. So we can summarize that down. Remember, our exponent represents how much we multiply a given number, how many times we multiply a given number by itself. So we can represent the Milky Way galaxy having a width of 1 times 10 to the 17th kilometers. That is still a quintillion kilometers. This is an example of the strategies that we will be putting forth for standards of scientific notation, in that we pick a representative number between 1 and 9.9. Very easy number that we can comprehend between 1 and 9. They're always one-digit numbers. And then we're going to multiply it by a representative value, a power of 10, to indicate the number of decimal places we have to move from that representative number in order to get our original number. So for the Milky Way galaxy example, we picked 1 as our representative number between 1 and 9.9, because 1 is the first number of the section. Then we multiplied by 10 to the 17th to indicate the number of place values that we moved. We're going to take this very similar approach and condense our bacterium length into scientific notation as well. So scientists say that the bacterium Bacillus anthracitus is about 0.003 millimeters long. Now, there are different scientific conversions that we can do for this. This is also equal to 3 micrometers, but millimeters is the most common term that we can reference in terms of length. I can imagine a millimeter rather well. So let's take the steps to convert this value into scientific notation. Step 1, pick a representative number between 1 and 9.9. Well, the numbers that we have here is zeros, and we have 3. So we're probably going to pick the number 3 as our representative number for the bacterium. All right. However, we want to multiply by a power of 10 to attain the original value. Our original value is smaller than 3. So how do we multiply by a power of 10 and get smaller? Well, we're going to use our fractional property of 1/10, or dividing by 10, is the same thing as multiplying by 10 to the negative first. A negative exponent is the same thing as that value in the denominator raised to the same exponent. So when we want to get smaller, we're going to use our negative exponents to get from 3 to 0.003. So let's check. We have 3 is our representative number, and now we want to figure out how many decimal places we're going to move from 3 to get to our original value. So right now our decimal place is here for our representative number. We're going to move 1, 2, 3 decimal places to the left, or multiply by 10 to the negative 3. This is the same thing as dividing by 1/1000th, because 10 to the negative 3 is the same thing as multiplying by 1 over 10 to the third, which is 1 over 1,000. If you divide 3 by 1,000, you get 0.003. So it works. Thanks for tuning in. See you in part 2.